Hi guys, welcome back to my YouTube channel, Mazatrol Tips and Tricks. If this is your first time here, my name is Phil, and I teach people how to run a Mazak CNC lathe while programming it with Mazatrol. If you want to see more of this type of content, be sure to click the subscribe button and hit the bell so you won't miss anything. In this video, I'm going to show you guys how to use the grooving process to groove on the face of the part. Alright, let's get started. Alright, the first thing we're going to do is go to the left button, go to the program screen, program file, and we're going to select a work number that's not listed up here to create a new program. So I'm going to choose work number 60 for this example. So push program, work number 60, input, and it couldn't find it in memory, so if it's a new program, push the program button. Mazatrol or EIA, we're going with Mazatrol. Workpiece material is aluminum. Max outer diameter of my workpiece is 3.25 inches. Inner diameter is 0. Workpiece length is 3 inches long. Max spindle RPM limit. I don't want to run the chuck past 2,000 RPM for this entire program. Finish allowance on X. This is for the turning tools, but it's not the grooving tools. So on this program, we're only going to have grooving tools, so we could leave these values at 0 if we want to. Stock removal of work face is 0. What I'm going to do is machine the face of an existing part, the OD grooving process example. I got enough stock on the face of it, so that's the part that I'm going to use. Down arrow. First thing we're going to do is turn on the coolant, so push the 3 arrows, M code, coolant on, down arrow. So now what we need to do is start programming the face of this groove. So here's our workpiece example. The outside diameter is 3.25 inches, and I want to put a groove that's 2.2 inches on the ID, and it's 200 thousandths wide. So the OD of the groove would be 2.2 minus double the width of the groove, so that would be 1.8 inches in diameter. So push the groove button and then push face, the open geometry, and now we're going to select the trapezoid groove, which is the number 1, because we can control the chamfer and the radius at the bottom of the groove with this. Most of the time this is what we're going to use on this older control. So number 1, number of grooves 1, grooving pitch is 0 because we only have 1 groove. The width of the groove is going to be 200 thousandths wide for this distance here. Finish allowance, I want to leave 5 thousandths on the walls and the floor, so type in 0.005 input, and then surface speed for rough cut, auto pops up, I can just push auto, and I can increase the speed, 2,000 surface speed, and I can increase the feed rate to like 0.004. And then the depth of cut, this is the pecking depth of cut for a chip break. If you want to have no chip break, you would put the depth of cut larger than the depth of the groove. So roughing tool number, push tool data, and groove edge is what we're going to be working with. So tool 9, offset 1. We're going to finish it with tool 9, offset 1. So now the starting corner on our print, it says chamfer 20 thousandths by 45 degrees. So that's the starting corner that we're going to put in there. 0.02. The starting point on X. On a trapezoid groove, X is programmed to the inside diameter of the groove. It's not the outside diameter of the groove. So even though the tool is going to be probed as an OD turning tool, you program to the ID of the groove for groove number 1. So 2.2 is our starting point on X. Starting point on Z is the face of the part. The final point on X is going to be 2.2 because this is a straight groove. And the final point on Z is going to be 200 thousandths deep. And then it has a 30 thousandths corner radius typical on both of these corners. So 0.2 on the depth. In the final corner, push the radius button, 0.030 input. And then we can choose the surface roughness of number 7, down arrow, and then N. And we're done programming the groove. So now let's take a look at the geometry of it. So push the right button, go figure check. And there's our groove, but I need to increase the scale, so let's blow it up, store, scale, 0.3. There, now we can see the groove. And now let's run the tool path. So left button, program, check, and then check continue. And then that's finished. And then you notice the groove graphics. This is the center line of the radius of one side of the grooving tool. So the area above here is the width of the grooving tool, and that's why it does not appear that it's cutting on this graphic, because this is the center of one side of the tool. So now what we can do is we can actually run a simulation. Toolpath erase. So go to program. All right, go to program, simulation, push auto because it won't run unless the machine's in auto. Push the right button, push simulation ready, and then push simulation start. So here's our grooving tool. And then it's going to run the finish pass. And it's done. So if we go to the layout screen, it said it's going to take 27 seconds to run that groove on the roughing and finishing operations. All right, let's run it for real. Let's set the work shift. Position. Come over here. All right, that looks good. Program file. Z offset teach, 0 input. And then auto work number, program number 60. And we're at 0. And there's our groove at the face of the part. So let's go ahead and run that now. Turn on the coolant, and we're ready to run. And that's it. And there's our workpiece with a groove in the face of the part. If you like what you see, go ahead and push that subscribe button and click the bell so you won't miss any future videos we have coming out. Thanks for watching.